So, about 24 hours ago, a little less than that actually, I think I might have discovered a way to define the largest possible finite number, which is interesting because it means that anything you do to try to make this number larger turns it into infinity. So what I first did, as I was thinking of, the limit of, like x as it approaches 0 of something like 1 on x, right? So this is infinite, right? 1 and 0 we can't evaluate. But as x approaches 0, it gets smaller and smaller and smaller and smaller. So the inverse of that is exceptionally large, and it grows. Explodes off to infinity. Right. So this will be coming from the right. Right? So, yeah. Like that. Well, what if, instead of doing that, what we did is we looked at taking the limit of x approaching that x, which is approaching 0, right? An easier way to think of this is to break down a limit. There's two things happening when we take a limit, right? First off, you are finding you're finding a value, right? And that value is the closest possible value to the point that you want to evaluate. But you can't evaluate your point directly, right? So something like this, right? So what we're trying to do is, given m, right, we're trying to find some n, which is the closest possible approximation to it that we actually can evaluate, right? And then the second thing that you do when you take a limit is you evaluate your function at n. Right. So you're given, f of m, and what we're trying to do is we are trying to evaluate it at m, but m is not, we can't evaluate it directly, so we're trying to find an approximation with n, and it would probably be better if I use different letters for this, and n ideally is so close to m that it's effectively indistinguishable from it, right? But it is different, it is distinct from it, right? So n is going to be the closest, by definition, n is the closest possible scalar quantity 2m. Alright, let's say these are reals. Right. Okay. So, if we're doing something like this, well, now n is the closest possible value to 0, right? L of 0 is n, so n is the closest possible value to 0, right? Well, and if we evaluated 1 over L of 0, it must be infinite, right? Because of this up here. Because the limit as x approaches 0 of 1 on x is the same as evaluating 1 over L of 0. So now we should be able to do this. L of 0. Now this is going to be the second closest possible value to 0. And now 1 over this will be finite, because as we move away from 0, we know that the values of 1 on x fall. We know that it decreases. We know that they're finite, and we know that they fall. They decrease in value. So that one closest to 0 is infinite. But as soon as we step away from that, it becomes finite. And more importantly, this is the largest possible finite number. I'm going to call it scalar quantity. Because I've expressed before how I feel about the word number. Because this is going to have to be transcendental. It's going to have to be a transcendental number, just by its definition. The only way that we can find it, it has to be transcendental. So it's certainly not an integer. Alright. So it's not going to be a number as I would define it. Yeah. I'll leave you to ponder that. But yeah, note that this is this must be, by definition, bigger than things like Rayo's number.